Okay. So hi everyone. Today I'm going to talk about bridging the gap between CommonJS and ESM in Node. So quick self-introduction. I work at Igalia, as said before. I've been sponsored by Bloomberg on my work in Node. I'm a member of the Node Technical Steering Committee and the VA committer. You can find me on GitHub via the handle joychum. Now, since we're at the Web Hackfest, maybe not everyone here is familiar with Node, so I would like to give a heads up that this talk will contain some technical details from Node, but it is also more of a story about how we move this ecosystem forward by providing a path with non-breaking incremental changes. Something that also need to be done quite frequently among web engine implementers, because as we've also learned in the past 5 years, asking everyone in the huge ecosystem to make breaking changes to migrate is not effective, which I'll touch on later. It's also a story about how we experimented changes in a subsystem heavily relied upon by a big ecosystem, where every change can be a breaking change. I took this meme from XKCD, where someone fixes a bug to make the CPU not overheat, which ends up breaking someone's obscure workflow that interprets a temperature rise as a control. Things similar to this happen to Node quite often. Node uses Simver, but since it also prioritizes stability, it also resembles the web in terms of having to avoid high impact breaking changes. But what if every change is a breaking change? How do we minimize the impact? We'll get to that later. So let's start with a brief history of ESM in Node and see how we got to where changes were needed. Node was created in 2008, and in 2009, it added support for a module system proposed as part of CommonJS. In 2015, JavaScript got a new standardized module format, which is generally called ESM these days. A group of contributors started the design and development of ESM support in Node from 2015, but it took a very long time, and there were a lot of debates around the interoperability between the existing CommonJS module system and the new ESM system. So after about 2 years of discussion, in 2017, the initial implementation was finally released in 8.5. Then there were like 2 more years of debates and collaboration. The design was kind of changed multiple times. Finally, the support for ESM was unflagged in 2019 and stabilized in 2020. So that was about 5 years ago. When ESM support finally reached stability in Node, it already supported importing CommonJS from ESM. Like here, you can import the module.exports object from CommonJS into ESM as the default export, like the logger here. You can also import name exports from CommonJS into ESM, which are detected using static analysis that work with common export patterns, like the log function being assigned to module.exports as a property here. And in ESM, in Node, require is not available as a context global. So if you have to load CommonJS dynamically from ESM, you have to create your own require in the module. And when you import a path from ESM in Node, unlike require, you have to specify the file extension and does not support resolving from directories. There was also support for things like top-level weight, dynamic import, and more specific things about ESM at the point. But for the context of this talk, these are the most important ones. On the other hand, in the existing CommonJS, which was the vast majority of the Node code in the ecosystem at that point, there was only very limited support for loading ESM. You could not require a ESM in CommonJS. Dynamic import works, but it returns the promise. So it can only be used in asynchronous paths. So at that time, CommonJS could not load ESM without coloring the whole dependency graph async. But the majority of the ecosystem still run effectively on CJS. So some packages wanted to use ESM without breaking users and losing popularity. So they started to invent all sorts of workarounds. One of the very popular choice was to transpile ESM to CommonJS, and these are called full ESM. But this caused a new problem. So when the transpilation was done somewhat magically by tools or frameworks, developers see their code as ESM, but Node only sees CJS. So then when the transpile code load real external ESN dependencies, developers will start to see error require ESN from their code written in the ESN format, which will be very confusing. If you search for error require ESN on the internet, you can see a lot of people struggling with this. This also creates a ripple effect. The more code in the while are run in CommonJS via transpilation, the more users and transitive dependencies also have to stick to CommonJS as a execution format. So another workaround that packages do was to ship both. The supply CommonJS to CommonJS, ESM to ESM. And one of the most obvious side effects of this is that it doubles the size of Node modules. So yeah, this just doubled. So apart from the duplication, dual packages are difficult to get right. For example, if you have an ESN consumer that loads two different dependencies, like here, A has one CommonJS dependency B, and another one is in ESN D, and they both in turn load the same package C via different path. Well, then you end up with two versions of the same package in the same graph, and not every package is set up correctly to expect two versions of itself in the same graph. This can lead to some very tricky bugs. And all this actually demotivate the adoption of ESM. So Titus has this nice tool that surveys the module types of the top high-impact NPM packages periodically. I took the data from there, and as you can see, many package authors chose to ship both CommonJS and ESM to maximize compatibility, that is labeled dual here, or they chose to ship transpile CommonJS, which are labeled full here. And after 5 years, since ESM stabilizing Node, only about 11% are shipping real ESM. The others either ship CommonJS or some form of CommonJS. And as you can tell, the growth of ESM wasn't particularly fast. And after all these years, more packages were actually inclined to ship dual instead. Now, for package maintainers, they either they enter a pick your poison situation. Either they ship ESM only and lose popularity among users, since most people are still effectively running CommonJS, no matter it's transpiled or not. Or if they ship CommonJS, they might run into issues with their own dependencies that migrate to ESM. If they ship transpile ESM or dual ESM, the setup can be difficult and annoying. In the case of dual packages, it's also difficult to get right and increases the size of the distribution. Now, what if require ESN gets supported? Most of these problems would just go away. Like full ESN and dual packages would no longer be necessary. It will only become a choice between ESN and CommonJS, and it's up to the preference of the package author. And most authors these days prefer to write ESM for new code anyway. It would be much nicer for them to just ship what they write directly. And users can do incremental upgrades for different parts of the code base instead of having to go into a all or nothing situation. Well, then why wasn't required ESN supported in the first place? Well, first of all, not that many people knew that it could be done. Those who did give it a try in 2019, but they didn't pursue it further after some technical debates and challenges. And then we had this misleading documentation saying that ESN are async, therefore cannot be required, even though in the spec, ESN is only async when it contains tuple overweight. And most people who were not involved in ESN, like myself before, kind of just believed what the documentation said. So time went by and people stopped trying. And then many years later, I happened to look into the ESM implementation in VA because I was investigating a memory leak, and I noticed that the implementation, which follow the specification almost to the letter, can resolve the evaluation synchronously if the module does not contain tuple-level weight. And then I confirmed this later with people who worked on the specifications, like Little Dan, who wrote those lines, that this was intentional, and this semantics was also relied on by bundlers. So this means, as a host, Node can implement something like this. This is pseudocode. In reality, this needs access to native VA APIs, but the gist of this is to implement require ESM, we can just fetch the module graph and link them synchronously first. That part is up to the host, so we can make it synchronous. And then we can check if it contains tuple-level weight. If it does, we throw and say it's not supported. Otherwise, we evaluate the module synchronously. And the specification guarantees that at this point, because it has no tuple-level weight, the evaluation of a synchronous module should finish synchronously. And we can just return the namespace to the user with evaluated values. And this check actually is not a novel concept. For example, service workers also disallows asynchronous module graphs. That the proficiency specification also says something like, if the module is async, it should fail. This even saved us from having to add an API to VA to check if the module graph is asynchronous, because it was already added in VA for Chrome to implement this for service workers back in 2020. The specification side had also been brought up in early attempts of require ESM in Node back in 2019, but somehow the work didn't get done. So I learned about all this in 2023, and I discussed with other contributors about implementing require ESM. The problem was, though, if we go back to this pseudocode, you can see for this to work, we need a way to fetch the source code and link the static module graph synchronously. But in 2023, the ESM loader in Node has like self-imposed asynchronous code everywhere. And underneath, it was like 3,000 lines of code that I had barely read before. So I thought, okay, I'll leave it to other people who are more familiar with it to refactor, because module wasn't really my jam. So an issue was opened to call for help to refactor out all the promises from the module loader, and I moved on to work on other things. So a few months later, I was working on the compile cache, and I ended up refactoring the compilation part of the ESM loader, and I reading the code a bit more. And I realized maybe instead of refactoring that 3,000 lines, it would be easier to just write a new synchronous and trim down ESM loading path for require. I could already see it in my head. I know lines added would be easier to backport than lines changed. So this felt pretty promising. I also got support from Bloomberg to work on this. So I started working. So I prototyped it a bit. I asked other contributors first to test the temperature in the room because I wasn't really sure back then. And I opened the pull request, and the reaction was very positive. So no one was saying that this should not happen. It was just lacking volunteer to actually do the work. So there were some edges that needed more work, but we agreed that those can be follow-ups. And nothing comes up perfect at the first try anyway. We can always iterate while it is behind the flag. So I added more tests and fixed more bugs, and I got this pull request landed. But landing the first pull request was just the beginning, and that turned out to be the easiest part because there are already a lot of user-land conventions and workarounds for the lack of require ESM. So we need to make the built-in version work with those. In the following month, I got a lot of help from contributors and package maintainers to test it out on the packages in the ecosystem, and we'll work on more features to improve interoperability while trying not to step on the toes of the existing code in the ecosystem. So here is the release and support schedule of Node. If require ESM ends up having any high-impact breaking behavior and have to be semi-major, then the last LTS that doesn't support it by default will be 22 or even 24. Then package authors would need to wait until their end of life to start transition. That would be 2027 or 2029. But if we can keep it non-breaking and send reminder, we can backport this to older LTS, and package maintainers can start migration a lot sooner. It could be a 4-year difference in the timeline. So that's why we have to kind of minimize the ecosystem impact of this and make it as non-breaking as possible to make it back portable. So the first thing we needed to figure out was, does the lack of support of top-level way matter? To understand the impact of the ecosystem, I wrote a few scripts to analyze the high-impact packages. It comes down to basically just try requiring all the packages and see if they fail. If they fail, just analyze the reasons. We tested on the top 5,000 high-impact packages on NPM. More than 400 of them are dual, and more than 500 of them are full ESM packages, which already don't use top-level way anyway because it's not supported in those formats. About 500 of them are real ESM, so let's break it down. It turns out that among the real ESM packages, only 6 uses top-level way. 3 are waiting on FS APIs that have synchronous counterparts, and they were using the synchronous version before they got converted to ESM anyway. 2 are awaiting a dynamic import of Node buildings in case they are not running on Node. So we added process.get-built-in module to fill the gap. The remaining 1 package only has minified code, so I couldn't tell for sure. So yes, the 1 package out of the top 5,000 might actually need top-level weight. So from the sample, we can probably safely assume that top-level weight is mostly intended for entry points and scripts. They are actually pretty rare in packages that need to be loaded by a different code base. So we can at least say, well, require ESM works for 99% of the high-impact packages. For the other 1%, they can still be loaded with import, dynamic import. But we have something that's good enough. We also confirmed that unflagging it do not break the usual ways to load these high-impact packages. And then we also did a bunch of research into how to help the existing code transition into shipping ESM. I won't be able to cover them all, but I'll pick a few that are more representative for implementers. So first, full ESM, the ESM transpile into CommonJS, turned out to have some special traits that we need to mimic. So a key difference between CommonJS and ESM is how they handle default exports. In CommonJS, the name exports are assigned to module.exports, which is returned by the require call. So on the left, the require call could just return the logger class, because that's being assigned as module.exports itself. In ESM, people tend to use the export default syntax to replace module.exports assignments. But that will actually be put on a separate default property of the namespace parallel to the name exports. Like here on the right, you can see that the logger is the property of the imported namespace object. It's not actually directly returned as by the dynamic import call. So, and this shape is mandated in the spec. So to handle this difference, when transpiling ESM to CommonJS, bundlers and transpilers have developed this convention. They make the exports object shaped like a ESM namespace with the default and name exports being separate properties, and a special marker __ ES module. Then on the consumer side, if the consuming code is also full ESM, the transpile code would contain some adapter to unwrap the default exports in the presence of this marker. So here, the transpile consumer code can unwrap the logger correctly. Now, suppose a package was previously shipped as transpiled or full ESM, and now it wants to ship itself as a native ESM and get rid of the build step. But the consumer code may be maintained by someone else, and that could still be full ESM. And if we return the module namespace as is, as you can see on the right here, because there isn't a ES module marker for the transpile code to recognize the shape of the namespace, it won't be able to unwrap the logger from the default property correctly. So the solution was basically follow what the bundlers do. Let Node add a ES module marker when there are default exports, so that the consumer code and the module code can still be migrated independently. But the problem is ESM namespace objects are not mutable. Even as a host, we cannot just add a new ES module property to it. So we had a long thread to brainstorm with folks from different projects about how to do this. There were multiple ideas to hack around this. Either we put it on the prototype chain, or we copy the property descriptors over to a new project object, or we return a proxy from require. Or we can use a new module that re-exports from the original module and put a module marker on top. So I implemented them all and did a bit of performance analysis. So here are the benchmark numbers from loading a bunch of real-world modules as benchmark. As you can see, the impact on module loading itself is very minimal. But I also benchmarked the performance of accessing the exports from the required ESM, which matters for full ESM consumers. The previous examples were a bit simplified. In reality, they do not cache what they get from the returned object. They always look up the exports dynamically from the returned object to maintain the live binding. So as you can see, the performance numbers vary greatly here. The fastest one was suggested by Bun, which puts the original module namespace on the prototype chain of the return object. But this would make the original export names no longer enumerable. The second fastest one overall uses the source text module facade, which wasn't as fast on the first try, but it has enumerable keys and look the most similar to the original results. So behavior-wise, it's the most desirable one. So then we did a bunch of optimizations on this approach. Most importantly, we only use the facade when the original module contains a default export. And we also cached the facade compilation. And we brought the numbers to a satisfactory level. So that was what we went with eventually. And the default export difference can also be a problem for packages that are previously written in CommonJS and now want to migrate to ESM. So previously, this is how you would write a CommonJS module if you want both ESM and CommonJS users get both the default exports and name exports properly. As long as you assign to module.exports explicitly, the static analysis can detect name exports from ESM for ESM consumers, like the .log here. Now, if you upgrade this to ESM, because ESM doesn't put the name exports on the default exports object, you would need to assign yourself for CommonJS to get the name exports. That is not too hard, but the default exports are now different for CommonJS users because it's now placed as a separate property named default. So like here, the CommonJS users have to unwrap the logger from the required result themselves. That means the migration will be a breaking change for CommonJS consumers. This is not a problem if the module doesn't have default exports, but a significant amount of them do. And in that case, Node needs a hint from package authors to customize what required ESM should return. And we can unwrap default based on the __ ES module marker because existing full ESM code would need that to be left to them. So we had to add another marker. And we chose module.exports with a string exports because export something as module.exports seems easier to read and remember. So with this addition, a CommonJS package can migrate to ESM while maintaining backwards compatibility to both ESM and CommonJS users, even when it has default exports. So we talked about full ESM and CommonJS. Now, what about dual packages? Here we have a common pattern of dual packages to prevent the dual package hazard mentioned before. They may use the no exports condition in package.json so that when the package is loaded in Node, they always supply the CommonJS version to both require and import to avoid having two copies of the same package in the same graph. In other environments, like when being bundled for the browser, they supply the ESM version. But now that we have require ESM, on newer versions of Node, they can always supply ESM to require as well. That seems easy, and they can then just drop the transpile CommonJS from the distribution, right? But we found out that not every package wants to do this so quickly. some of them still have to support older versions of Node for some time, even though they would like to go ESM first when being loaded on newer versions of Node. So we need a new export condition for Node that supports require ESN to pick up ESN even when it comes from require. Now, bundlers actually already have a conventional condition named module that can be used to supply ESM to require, which allows them to transpile and produce cleaner code. We tried picking this up, and to be cautious, we implemented first and then tested it out on high-impact packages. Unfortunately, we found out that existing users of this condition, including some very high-impact packages like the SDK of AWS and Sentry, are using non-Node resolution rules in their ESM code. So if Node pick up these modules that are using resolution rules only supported by bundlers, we will break them. So as much as we wanted to implement the existing condition and save people from the mental burden of like one more condition to avoid the breakage, we ended up having to add a new separate condition instead. This is called module sync. Since require, we expect them to be synchronous. So with this condition, early adopters can supply ESN to both require and import on newer versions of Node to test things out and fall back to CommonJS on older versions of Node. And hopefully, when they no longer need to support older versions of Node, they can just drop all that and do this. And hopefully more packages can just be this simple in the future. So we did a lot of research. We added a bunch of features to improve the adoption of ESM. Most of these was done on the main branch during the period when 22 and 23 were the current releases. Require ESM was unflagged in 23. Then we started the backporting. Now, backporting to 22 was relatively easy because the release branch was not too old, but backporting to 20 was really challenging. So I first tried finding all the commits that are related to the module loader and also missing from 20. There were like 119 in total. And as I walked through them, I realized that some of them had breaking changes that would be difficult to modify into a shape to be backported. So I changed the strategy, and I took a bit of time to identify 32 commits out of them that were just essential to require ESM. And because many related changes were left out, almost all of them needed to be rewritten a bit for the 20 branch. And I had to verify that the commits were adapted correctly after the changes. So I also wrote a script to diff the diffs. And this is what the diff of diffs looked like. I tried to keep track of all the changes in the backported commits and summarize them into the pull request description for posterity in case something went wrong. And I think it didn't. And finally, this is where we are now. Require ESN is currently a release candidate. That is the last state of the experimental stages in Node. It's available without flags in 24, 22, and 20. We plan to stabilize it soon after it's more battle tested. And at that point, that will just be a documentation change. So last month, Node 18 reached end of life. So now all active LTS releases of Node support require ESM. And we are already seeing popular packages that either started shipping ESM only or are planning to do so. We still have a bit more work to do, like consolidating the synchronous and asynchronous linking path, because we kept them separate for the ease of backporting. Now we need to kind of consolidate them back together. We also need to provide in-thread synchronous loader hooks for the ecosystem to stop depending on the internals of the ESN loader themselves. And then we also need to improve the performance of ESN because there is still a gap between ESN and CommonJS loading. So lots of work, but it looks promising, especially now that we have more feedback from packages adopting ESN for real. So yeah, that's the end of my talk. Thank you for listening.
Hi, do we have any questions in the audience?
Here, Mike.
Oh, sorry. This was a big pain point for me, so thanks for doing this work.
Thanks.
Well, perhaps I should.
Yeah, this is such an amazing story, and it's really cool to see it. And thank you so much for all the work you did, especially the backporting. Sounds absolutely horrible, but I really appreciate it. In the early part of your slides, you had showed like graphs of adoption between, I think, like ESM and FO and CJS and these things. And it looked, I was just really surprised. It looked to me like ESM adoption was going down through 2024 and 2025.
So I think one of the key reasons was that this tool, it detects the dual packages based on certain patterns, and that has a lot of, I guess, false negative. So it was actually detecting certain dual packages as ESM. So that was why, for example, I think somewhere there in the pie charts, I kind of corrected them a bit because some of them, like, for example, I mentioned that 500 of them are ESM. Actually, the tool produces 600. 100 of them are actually dual. So that's why the stats changed a bit.
Hello. I just wanted to add on to the part earlier in the presentation regarding why require ESM was not originally looked into more. And it was because on the the Node modules working group, we had assumed that top-level await would be far more prevalent than it ended up being. So I think it's a good lesson to always maybe back up your assumptions with data, perhaps. But yeah, I thought that might be interesting.
Sorry. Well, I had a question as well. I'm not sure if you mentioned it, but you started out with 119, almost 120 commits for the module code. You had to whittle it down to almost, 33, right?
Mm-hmm.
Because of the backporting and everything. After the end of all of this and require ESM merging, have you found any new wisdom regarding designing such features that require long backports?
I would say I would say like my original instinct about line sided will be easier to backport than line change was correct. It did save me a lot of time. And also a lot of conflicts I had to deal with were kind of like mass stylistic refactoring, which weren't that often, but sometimes they show up. So those are easier to deal with, but when they come up like frequently enough, it can easily get into a situation where like you need to change every commit, and sometimes they're not as straightforward, so you can mess up a bit. So I guess like when you have something that you really need to backport to older branches coming, maybe try to back down a little bit on the mass stylistic refactoring, especially not the ones that cannot be automated.
So my new PR regarding ESLint on all the code base is not going to be accepted.
I think in Node generally that would not be, like you need to do them incrementally, or like per file basis, instead of everything has to be done in a single commit.
Fair enough.
So something that was good to hear was that you looked into existing patterns and tried to make this work with those as best as you could. And I'm curious if you looked into like non-Node use cases where like package authors, it's good that they can support Node still, but I think other runtimes also do similar sort of interop between CJS and ESM. I'm interested if you looked into how close Node's implementation is to some of those, or is it still a case where package authors might need to think a bit more with their code if they're trying to target both?
I'm not sure if I got the question correctly. It was the question like whether we were looking into helping other runtimes to implement the interop?
More so about the Node's implementation compared to, like, I think Bun also has something similar. And is it where an assumption for how this would work in Node would also apply to Bun, or is this something where the package ecosystem still needs to think a bit?
I see. The principle was follow what the bundlers do, because everyone follows what the bundlers already do. And because, as you can see, a lot of people were already running full ESN. So the behavior implemented, the full ESN behavior implemented by the bundler was like already the de facto standard in the ecosystem. So we just follow what they do.
All right. Thank you all for all the questions, and thank you for the presentation, Joey.
Thank you.